No clue. Not my call. Not my call. Good morning, everyone. It's a Monday morning. I am hyped. I just spent all weekend in the woods. It was great. It's fantastic. You ever sleep in a hammock? In a sleeping hammock. It's this amazing thing. It's not a regular hammock. It's like this hammock with like really strong like straps on the side, right? And then you got a bug net over the top, and then you got a rain fly over the top. It's basically like you're camping in a tent, but it's a hammock. It is so comfy. It is the best night of sleep I've gotten in like 2 years. Just saying. Anyway, to this. So here's my reminders for you first before I talk about my goals. Reminders, you do have an assessment on Google Classroom that is due tomorrow at 2 o'clock. I initially assigned this thing Friday morning. I wanted to give you the appropriate amount of time to get it done, so it's been on there. But it is due tomorrow at 2 o'clock. Please make sure you're getting that done. I believe one or two have already submitted it. Haven't looked at them yet, but just in the chat dropped down to 0, so now I'm sad that they left me. Anyway, back to this. My goal for today, we are taking a slight step forward. Now, in the past few weeks, you guys have been constructing samples for me. Samples or experiments in which you came up with a topic, and then you got that approved. We discussed that, and then you went on and came up with questions, and we discussed that, and I'm still waiting on some people to turn that in, but we are taking a slight step forward with that. Eventually, we're going to take those surveys that you came up with and actually put them to use. But before we do, I want to show you the next chapter that we are going to be walking into, which is talking about graphical displays. Once you have your data, what do you do with it? There has to be an analysis done. And that analysis can be done on the graphing calculator, of course, but more importantly, there has to be some level of graphical display that we actually come up with. Now, what's really nice is that everything that we do today is on Google. Google Drive, Google Sheets, Google Docs, Google Classroom, Google everything. And Google Sheets is very intuitive when it comes to that kind of stuff. Eventually, when you input your data, you can use Google Sheets to get a lot of this stuff done, but I need you to understand what you are looking at. So the goal of today is to talk about graphical displays and the things that we can get on the graphing calculators that you guys have on your Chromebooks. Now, to get this, hold on now, there's a bell. Yes, I already did. Yes, I already submitted my attendance. Yes, thank you. Now, to get this thing started, I do have a brief video to show you first, just as a cautionary tale, and then I have some examples for you guys to look at as well. Again, the goal of today is graphical displays. I want to teach you how to do this kind of stuff, but you do have to be cautious in regards to that. Now, let me set this up. I had to move this all around last week. Make sure my volume is actually where I need it. There it is. Good. Let's hit this.
A toothpaste brand claims their product will destroy more plaque than any product ever made. A politician tells you their plan will create the most jobs. We're so used to hearing these kinds of exaggerations in advertising and politics that we might not even bat an eye. But what about when the claim is accompanied by a graph? After all, a graph isn't an opinion. It represents cold, hard numbers, and who can argue with those? Yet, as it turns out, there are plenty of ways graphs can mislead and outright manipulate. Here are some things to look out for. In this 1992 ad, Chevy claimed to make the most reliable trucks in America using this graph. Not only does it show that 98% of all Chevy trucks sold in the last 10 years are still on the road, but it looks like they're twice as dependable as Toyota trucks. That is, until you take a closer look at the numbers on the left and see that the figure for Toyota is about 96.5%. The scale only goes between 95 and 100%. If it went from 0 to 100, it would look like this. This is one of the most common ways graphs misrepresent data, by distorting the scale. Zooming in on a small portion of the y-axis exaggerates a barely detectable difference between the things being compared. And it's especially misleading with bar graphs, since we assume the difference in the size of the bars is proportional to the values. But the scale can also be distorted along the x-axis, usually in line graphs showing something changing over time. This chart showing the rise in American unemployment from 2008 to 2010 manipulates the x-axis in two ways. First of all, the scale is inconsistent, compressing the 15th month span after March 2009 to look shorter than the preceding 6 months. Using more consistent data points gives a different picture, with job losses tapering off by the end of 2009. And if you wonder why they were increasing in the first place, the timeline starts immediately after the US's biggest financial collapse since the Great Depression. These techniques are known as cherry picking. A time range can be carefully chosen to exclude the impact of a major event right outside it. And picking specific data points can hide important changes in between. Even when there's nothing wrong with the graph itself, leaving out relevant data can give a misleading impression. This chart of how many people watch the Super Bowl each year makes it look like the event's popularity is exploding. But it's not accounting for population growth. The ratings have actually held steady, because while the number of football fans has increased, their share of overall viewership has not. Finally, a graph can't tell you much if you don't know the full significance of what's being presented. Both of the following graphs use the same ocean temperature data from the National Centers for Environmental Information. So why do they seem to give opposite impressions? The first graph plots the average annual ocean temperature from 1880 to 2060. In fact, a rise of even half a degree Celsius can cause massive ecological disruption. This is why the second graph, which shows the average temperature variation each year, is far more significant. When they're used well, graphs can help us intuitively grasp complex data. But as visual software has enabled more usage of graphs throughout all media, it's also made them easier to use in a careless or dishonest way. So the next time you see a graph, don't be swayed by the lines and curves. Look at the labels, the numbers, the scale, and the context, and ask what story the picture is trying to tell.
Get that, and let me bring you to this website. Click. There we go. Oh, I'm already at the bottom. I was kind of skimming through this before. There we go. So here are just some examples of misleading or just mischaracterized graphs. Not this. This actually, that's just another video. I got to scroll down to the next one. Click. There we go. So these graphs can tend to show up in newspapers, magazines, TV shows, websites, things of that nature, and they're used to influence people to feel a certain way. When you have a graph up there and it shows something that is just extraordinary, like for example, look, global visitors to the Times website. That's crazy. Look at that. Like the people visiting the Times website has absolutely exploded. But like, you guys don't remember this time. When were y'all born? 02? 02, 03? Yeah. You don't remember a time when people didn't have like personal computers at home. Like you've grown up in this age where everybody has a personal computer at home. Back in 2004, 2003, things of that nature, a lot of people were still using newspapers. Newspapers were these paper things that you could purchase at the store, and they had like ink on them, and they told you the news. It was crazy. And they gave you one every day. Actually, you had to buy it, 50 cents. So this graph, although like, wow, that looks pretty amazing, is very, very easily like, well, it's not impressive if you think about what's actually happening before 2004. They kind of showed that in the job loss graph, where if you go back a few years, it was right after one of the biggest collapses in U.S. history. Yeah, let me change the size of the screen real quick. Chapow. And chapow. There we go. So let me go to here. Skip to here. There we go. So this was a graph. It's like if the Bush tax cuts expire. I believe this was from 2010. I'm not entirely sure what year this is from. But it's like, oh no, 2012, 2013. Well, right now, here's the top tax rate. And if the Bush tax cuts expire, boom, it's going to skyrocket. that is absolutely going to skyrocket. Like that looks like, if I actually could draw this out, look at this. Hold on. It's like do-do, 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 do-do. That's like 1, 2, 3, 4. That's like 4 times as much. 4 times as much. But in reality, if you look a little bit closer, that's 35% and 39.6%. Yes, it's going up, but it's not going up at the scale that they make it look like. Now, I do have to ask you though, are they lying? They're not lying. They're not lying. They are absolutely not lying. Look, 35%, 39.6%. There's the scale. Now versus January 1st, 2013, they're not lying. But they're showing it to you in such a way to kind of get you to be like, holy crap, my taxes are going to go up like crazy. But they don't say that. They don't say that. They just kind of show you it visually. Let me show you another example. Let's see here. Oh, this one's hilarious. This one is absolutely hilarious. Watch this. So unemployment rate under President Obama, blah, blah, blah. Obviously, how old were you guys? You were like 5 or 6 years old when the financial collapse hit in 07, 08. But check this out. This is really weird. Actually, you know what? I'm not even going to point it out. I want you to point it out to me. What's wrong with this graph? There's something terribly wrong with this graph. Say again? It's always around 9. Yeah, I mean, clearly, I mean, it looks like it's kind of like going up and down, up and down, up and down. But there's some, look deeper though. There's something very, very specifically, sneakily done where they actually are lying to you. Oh yeah, it does. October, November. That's right.
Wait, were you trying to say that November comes before October?
They're not lying to you there. They're lying to you right here. Look what I just circled.
It's the same.
But it's not. It's supposed to be like that. You know what I'm saying? Which if it was like that at the end, you'd be like, whoa, maybe we're getting better. But somebody decided, nah, I'm just gonna leave it there for the fun of it. Because again, it misleads people. It misleads people. Oh yeah, that's what it should have been right there. There you go. Let's see. Wait a minute. Sometimes you get really messed up things. No, not that one, not that one. I was trying to find one very specifically. Like this one. This is actually an advertisement in a magazine. Can somebody tell me what the heck this graph is even trying to say? Like, I understand it's for itch relief. I totally get that. But what's it really displaying? I don't know. Yeah, I mean, this one's a little taller. But yeah, I don't know. I thought Lacanine or what? I don't even know how to pronounce that. I thought that was the. I don't know what's going on here. See. Well, let me ask you a question. If I presented to you an informational report trying to convince you of something, and I just kind of threw up some graphs, I'm like, hey, look, here's some graphs. You'd be like, oh, I guess he knows what he's talking about. Maybe. If somebody has graphs to kind of show, a lot of the time people don't even look at them. They're just like, oh, okay. I kind of get that a little bit. Here's a decent one. Here we go. Now, this one is actually a sneaky in the sense where they're hiding the information is in what they don't tell you. This is the cost of a 4-year degree versus your earnings, your income from a 4-year degree. So the blue line is tuition, room and board. And you can see over the past 20 years, actually it's probably 30 years now, you can see the skyrocketing cost of college. And yeah, the scale looks pretty good. The years, something to be desired, I guess. I mean, they go by 10 years and then this one's by 6, but I'll forgive them for that. And then you can see the red line is the average earnings, the average income of people. The thing that they don't tell you here is what is your income if you don't have a 4-year degree? No. What they don't tell you is that with a 4-year degree, with a bachelor's degree, up to 2010, mind you, this is 10 years out of date, you're earning somewhere between, around $45,000 a year. But without a 4-year degree, that graph would be like down here somewhere. Of course, that doesn't count for inflation. Of course, that doesn't account for cost of living. For example, a first-year teacher at Barnegat would earn roughly $50,000 a year. Okay, a first-year teacher down in Mississippi might be earning $35,000 a year. You're like, wow, that's a huge difference. But it costs a lot more to live up here. It costs a lot more to live up here. Let me give you an example. My first year of teaching, I taught in Maryland. How much does it cost to rent an apartment up in Barnegat, like in Atlantic Heights? Roughly $1,000 to $1,200 a month. It cost me $500 a month to rent an apartment down in Maryland. $500 a month. I know, it was sick. It was so sick. I mean, it was in a bad neighborhood, but still, that was awesome. I was earning, I kept a lot of my income. The cost of living was way down where I was, even though I was earning a comparable amount up here. And then I moved up here and I'm earning the same amount roughly, but I'm paying a lot more in like rent and expenses and things of that nature. So sometimes they don't tell you that. What they're trying to show you with this graph is, man, college is way expensive. Yes, it is. And that's not really that fair when it comes to a lot of things. But then if you don't have that 4-year degree, your average income might be down here. That is, of course, unless you have like certain types of vocational training, if you know what I'm talking about. Do you know how much a welder earns? A welder, like you weld metal together, like building projects and stuff like that. It's okay. A welder, after like an apprenticeship and like working for a company for a few years, they could be earning like up $80,000, $100,000 a year. Vocational training is worth it. Vocational training is worth it. Let's go to this one. This one's hilarious just because of the numbers. Just think about it for a second. Those are presidential candidates.
Oh God, everyone.
Yeah. Mitt Romney was the former governor of Massachusetts. Now he's the senator from Utah. Mike Huckabee, Sarah Palin, former governor of Alaska, and reality TV show host. What's wrong with the graph, though? It doesn't add up to 100. He redeemed himself. There he is. It clearly doesn't add up to 100. See, now the thing is, what they really were showing was this. This is in 2012. In 2012, these were favorability ratings. Favorability ratings. Meaning, out of 100% of people, 63% supported Huckabee, 60% supported Romney, and 70% supported Palin. Meaning, do you or do you not like them? That's what the real question was. So 70% of people were like, yeah, I like Palin. But then the same person might also say yes to Huckabee and yes to Romney. So instead of showing that favorability rating, they put these numbers together into a pie chart, which ruins it. Because pie charts are supposed to add up to 100%. This wasn't a vote. This was just, do you like them, yes or no? It's really weird. Let's talk about, that's another fun one. Welfare versus full-time jobs. It makes it look like welfare is exploding, but in reality, it's like, hold on, where's my pen? Here we go. It's like boom, 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 boom. 1, 2, 3, 4. It looks 4 times as much, when in reality, the difference between them is only 7 million. The difference between them is only 7 million. 4 times as much. No. I don't think so. Again, it's just the way that you put these graphs together. It's so weird. Click off of that. There we go. Now, I do have this video, which I'm going to save. I do have this video that I'm going to save. If we don't get a chance to watch this, because I don't want to watch all of this because it's a 20-minute video. Okay, I don't want to watch all of that because I have other things to get to. But this guy, Hans Rosling, amazing. Basically, it's like the next generation of how we look at data. Name a type of graph that you know. Name a type of graph that you've done in the past. A bar graph. What else? A pie chart. What else? A line graph. You've done crap like that. Those are the basic things. Yes. And those are the basic things that, yes, we're going to focus on a bit more today. And we're going to see how we can create those things electronically. And we're going to recognize how to determine shapes of things and 5-number summaries and all that fun stuff. But eventually there's this video. And again, this is like a 20-minute video, but it's the next generation of data collection, which is amazing. Because not only does he like show those patterns, but he shows it in such a unique way through time. It's amazing. I don't know. If you had a regular XY graph, you only have like 2 dimensions. You have an x-axis and a y-axis. You only have 2 dimensions. But this guy's talking about 3rd and 4th dimensional movements. He doesn't say that, but he shows it to you. And it shows a lot more. It shows a lot more. Anyway, perhaps we'll get to some of that. There's parts of that video that I want to get to. But in the meantime, ladies and gentlemen, if you would, I'm going to need 2 things specifically. I'm going to need those notebooks out and open. And if you don't, and obviously if you're on the computer, you already have it open, but I'm also going to need their Chromebooks out and open. The Chromebooks are going to be for the calculator. We're going to get to that. What is with the size of this? There we go. Click. Okay. Now there is going to be data that I'm going to put up on the board that you are eventually going to enter in your graphing calculators. Now I caution you, if you are using the graphing calculator on the Chromebook, every time you open it, it resets the data. Meaning if you close out the calculator after doing a bunch of stuff and then open it again, everything that you've done in the past is immediately deleted. So, word of caution, as we move forward with these graphing calculators, if you input a bunch of data, just be careful not to close it out. In years past, if somebody accidentally deleted stuff on their calculator, I could easily transfer data through a data cord, but I can't do that with these calculators that you guys have. Also, the notebook's out and open. Awesome. You broke my heart. You broke my heart in 1,000 pieces. You broke my heart in November before October. Let's see here. Let's call this graphical displays. Today is the 12th. First and foremost, if you had physical graphing calculators, I would make a big deal about, hey guys, how do you reset your calculators? But in reality, you don't have to worry about that. If you just close them and open them back up, they reset by themselves. But just for the sake of argument, if you ever needed to reset your calculators, you would type in the following commands. You would type in the second button, the plus sign, and 712. On my calculator, and I'm going to show that to you what it looks like, just so you have a reference for it, because we're not always going to be on the computers and whatnot. But if on the regular calculator, if you hit the second button, the plus sign button takes you here. You see 7 says reset, 1 says all RAM, and 2 would be reset again. It would say RAM cleared. Now, when you open it on the computer, it does say RAM cleared, right? Okay, one person nodding. All right, cool. But yeah, so you don't have to really worry about that. But again, for the sake of argument, I'm just going to put that there. But this is what we're going to do. First, I want to show you how we enter data. Entering data on the calculator, you would have to hit the following button. Stat, followed by edit. Do that for me now on your graphing calculators. First of all, where's the stat button? Where's the stat button on the graphing calculator?
Right next to the X.
Yeah, XT, theta n, stuff like that, right below delete. Right in the middle column of all this stuff, you can see that stat button right there. That thing will focus for a moment. And it's kind of focusing, whatever. But if you hit stat, you go to this screen. And then you see the word edit. This is how you're going to enter your data. You hit the word edit, you come to this screen. Now on this screen, you have what they call a list of lists. This is where you're going to enter your data. So basically, for the most part, as long as you have one-dimensional data, you could just be like, all right, 1, and then 2, and then 3, and things of that nature. Now check this out. Let's say I messed up 2. Let's say I messed up 2 and I put in like a 9 by accident. Oh, crap. I need that 9 to go away. I need that 9 to go away. So what a lot of people do is this. Check this out. What a lot of people do is this. A lot of people hit clear, and they hope for the best. I'm like, Mr. Murky, I can't get rid of it. I'm just going to keep doing it, bless you. I'm going to keep doing it again until it works. How do you get rid of it? Huh? I could, but what if I just didn't need that number? Yes, there is a delete button, which is right there, that DEL button. For some reason, it's the button to actually get rid of it. Watch what happens here. Click, and then it goes away. Really weird. So here's the first thing that I want you to do. I want you to enter data for me. In your graphing calculators, I want you to enter the following data right there. How many points do football teams score in the Super Bowl? Here are the total number of points scored by both teams in each of the first 51 Super Bowl games. The data are values of a quantitative variable whose units are known. Those are the numbers I want you to do. Now, I got to fix the screen a little bit because those who are on the computer have a glare right there. So I am going to have to move this a little bit. See if I can move it there. Let's see if that's... Yes. I want you to enter in all those numbers. There we go. So those, I fixed... The glare's not on those numbers for the people in the computer, but I want you to take a moment and enter that data. Enter that data, enter that data. Yes. Yes. You type in the number, you hit enter. You type in the number, you hit enter. Double check to make sure that your numbers are what they say they are. This was the 28-3 game, wasn't it? For the Patriots Falcons. All right. I'm going to do that as well on my calculator. These aren't done yet. It is embarrassing. You guys text a lot more than I do.
But I don't have a real calculator.
I'm doing a double check, make sure my numbers are correct. Always double check to make sure that your numbers are correct. And eventually, this is what you're going to have to do with the data input. Once you collect the data from your surveys, you're going to have to input the results of those surveys into a spreadsheet. Yep. Let's what's crazy is a couple of years ago, I think it was the Patriots and the Rams. It was like 16 was the total. It's like 13-3. What a game. What a game. Now, like I said, after you've entered your data, just do a quick scan of that data to make sure that the numbers are what they say they are. Because obviously, if one number is off, it's going to mess up some of the calculations that I'm going to show you in a few moments. There's this amazing video on YouTube, which is like they have a graph that they explore showing the scores of every NFL game in the history of football. You know how many years the NFL's been around? Like over 100 years, yeah. So they have every game in the history of the NFL on a graph to show like the possible score outcomes. It's really awesome. Now, obviously, there are certain scores that have never happened. You've never had like a 1-to-1 score. You have had 0-to-0 scores, though, believe it or not. Anyway, first, you enter your data. Zoom out, zoom out, zoom out, zoom out, zoom out. Then, I'm going to show you how to do something called a 5-number summary, just so we're all on the same page with this. Now, I'm going to write this down. We may have talked about this briefly, but I want to make sure we're all on the same page with this. Hit stat again. If you hit stat again, you come back to the screen, and then tab over to the right. If you tab over to the right, you come to this function called calc, which gives you all these options. The option that I am worried about is the first one var stats. If you hit that and then hit it again, it gives you all of this wonderful data. Now you can check to make sure that you typed everything in correctly. If you got the same numbers that I do, then you have it, because I double checked my numbers. Anybody nail it like right on the button? There he is. Got a couple. So there may be like 1 or 2 you may have messed up. Possibly. That's okay. We'll get there. We'll get there. That's okay. Now here's the thing. Don't worry about fixing it. Don't worry about fixing it. Getting these numbers right now is not the purpose. The purpose is how you get these numbers. How you get these numbers is by typing in that data, then going to one var stats, which I'm going to write down those instructions in a little bit. Again, it's not, oh no, I didn't get the exact number that you got, Mr. Murray. That's okay. Don't worry about that. You're not being tested on that right now. Now, there are a couple numbers up here that I'm very interested in. First and foremost, what the heck is this number? What the heck is this number? Oh. Huh? No. It would be labeled median. Yeah. How many Super Bowls did you have on that data chart? 51. Well, it's the number of data points. The number of data points that you were able to enter into the graph. Now, there's a couple other things that I'm interested in. I am interested in this number right here. This is your average. It finds the average for you. You know how to calculate an average on your own. Like you've been doing that forever. You add everything up, you divide by however many data points there are. Yes. But if you have like 51 data points, you're like, oh crap, I wish something could do it for me. There it is. It can do it for you. This is another number that I am going to be interested in right here. I'm going to talk about this number in a little bit. I'm not going to give you the definition right now. Oh, yeah, I'll give you a short definition right now. This is called standard deviation. You may have heard of this word before, standard deviation, but it's like deviation. When you think about deviating from something, it's differing. But what is it differing from? It's differing from the average. Some scores totaled above this. Some scores totaled below this. They all deviated in some direction. Some deviated positively, some deviated negatively. But what about the average deviation? If you're talking about average deviation, then we are talking about this concept known as standard deviation. It's very similar to that definition. Let me scroll down a little bit. You guys see the little arrow? There's a little arrow. That means there's more data. There's more data. If you scroll down, now that's what we're talking about. There's your median. Literally labeled median. Minimum, maximum, and then these QE things here. That's weird. What are these QE things? Ooh. Huh? Not quantity. That's all right. Median. Where is the median in your data? Where is it? Right in the middle. Right in the middle. Yes, the middle data point. The, ready for this? 50th percentile. The 50th percentile. What's halfway between the minimum and the 50th percentile? Think about that for a second. What's halfway between the minimum and the 50th percentile? What's halfway between 0 cents and 50 cents? Which is also known as a quarter. That's your first quartile. The first quartile is the 25th percentile. It's the first quartile. What do you think this is? It's the third quartile, or the 75th percentile. Have you ever drawn a box and whisker plot? Box and whisker plot? I'll show you. Oh, I'll show you. Let's write down some of this information. First and foremost, talked about entering your data. You hit stat and then edit. You want to get your 5-number summary, X bar, and standard deviation. I'm going to show you how to get the 5. That's a number sign, by the way, just so you know. Hashtag. But the 5-number summary, X with a bar over the top, and standard deviation. After you've entered your data, you hit stat. You tab over to calc, and you select one var stats. Now, as long as you do that, it will calculate a 1-variable statistical summary for everything that you've entered into list 1. It will calculate a summary of everything that you need from list 1. If you wanted to do something from list 2, then you would have to specify, hey, 1var stat list 2, which we'll get to. Question. On your calculators, because I'm not as familiar with it as I am this one, when you hit 1var stat, does it go automatically back to the home screen? Or do they have you enter more information?
Well, it goes into something, it has like 3 columns, and then you click enter, and then it says calculate, and you enter again, and then it should.
Can I see it real quick?
Yeah.
Just
Do it again.
go back to stat, go over to calc, first one, 1var stat. No, stop right there. Okay. So when you do that on your graphing calculators, I'm saying this for everybody, I'm saying this for the people at home right now because I'm talking to them. It says list, and then I believe it says L1, right?
Yeah.
Don't worry about frequency. Don't worry about that. But the first one, in your graphing calculators, it says L1. Now, what you could do if you entered data in a different list, you would then at that moment type in the list that you wanted it to do. So like, oh, do 1var stat with L2. Cool. And then you change it to L2, which we'll talk about. But this is it for now. Yay! Okay. Let's see. let's take a look at a graph of this junk. If you hit graph right now, hit graph right now, you'll see absolutely nothing. Congratulations.
Yeah.
You what? Good. It doesn't do anything. Because you got to turn some stuff on. Here's what you do. To see graph. First, we have to turn a plot on, or turn on a plot. The way you do that is this. First, you hit the second button, and then you hit Y equals. Typically, you would hit Y equals when you wanted to type in an equation. But for us, we're going to hit second and hit Y equals. And then basically, you tell me, what do you see when you do that? What do you see when you hit second Y equals? Absolutely. So you see this. What do you notice about all those plots, though? What specifically? You did say it, but I want to emphasize this. What's so true about all those plots? They're all off. You got to turn one of them on. So we're just going to go into the first one. You hit second Y equals, and then enter into plot 1. You're going to turn plot on by literally, I'll show you that in a minute. And then you select type of graph. You turn the plot on, and then you select the type of graph. I'll come back to that screen in a moment. But if you hit second Y equals, you go right here, hit enter on the first one. You come to this screen. You want to turn that plot on by literally, it's blinking on the word on. So you just hit enter, and then boop, it taps over to the word on. Now it's on. Yay, you turned it on. But you need to select the right type of graph. Now, there are 6 graphs up here. And for the time being, you are only going to be focused with about 2 of them. The first one is your typical scatter plot. We will eventually get to scatter plots. The second one is that line graph that you were referring to. Not going to be helpful for what we need, but okay. This third one, though, is important. This third one is not a bar graph. It's not a bar graph. Bar graphs are used for a very particular type of data known as categorical data or qualitative data. This is known for quantitative data. This is a histogram, is what they call it. It is a histogram, and we will be using that at some point. These 2 are known as box and whisker plots. I'm not really going to be concerned about this one. This box and whisker plot takes into account a concept known as outliers, but I'm not going to worry about that for now. We will deal with outliers in our own time. So we're only going to be focusing on this box and whisker plot. This one is something that you're never going to use. This is something that I only really teach to AP statistics. This is known as a quartile plot. This is for determining whether or not the data is actually normally distributed or not, but that's not something you're going to have to worry about. So you're really only going to be focused on these 2 graphs, a histogram and a box and whisker plot. So first, go over to the histogram. You got to bring the cursor over to the histogram, or not the cursor, but the blinky thing, whatever they want to call that. Bring it over to the histogram, hit enter so that it is selected. If you notice for the histogram, everything on the bottom changed. All of a sudden, there was no such thing as a Y list because we don't have to worry about it, and it's automatically set to L1, so oh, happy day. All right. I think we're good. We turned it on. We selected the right type of graph we wanted, the histogram. It's almost like hit graph. It's almost like if you hit graph right now, it's almost as if you hit graph right now, you will still see nothing. You'll still see nothing. Did you hit it and then you panicked for half a second? Whatever. Okay. So turn on the plot. Second Y equals enter. Turn the plot on. Select the type of graph that you want. In this case, we selected histogram. Here's the problem. If you actually hit graph right now, nothing happens. The reason why nothing happens is because your data is not in the right range. Your data right now, like this graph only goes up to 10. It only goes up to 10 over here and 10 over here. But we're talking about combined Super Bowl scores where the minimum was like 20. All of the scores are over here. That's where all the scores are on your screen. So we got to resize the window. Oh, we got to resize the window. Y'all see that window button on your calculator? Y'all see that? That's not how you resize the window, though. I mean, you could. You could. I know. I'm sending you in a lot of different directions. But check this out. If you hit window, look at all this complicated crap. If you hit window, look at all this complicated crap. You would have to resize your X-min, your X-max, your Y-min, your Y-max, your scale, your resolution, blah, 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 blah. Screw it. Screw it. What's the button next to window to the right? Zoom. Sorry if I yelled. Zoom. This is where you want to be. And if you go down to option number 9, look at what option number 9 says. Now, this is no joke. If you hit zoom stat, you are going to see something. You jumped ahead of me. If you hit zoom stat, you will see this. This is a histogram. It's a nice looking histogram too. This histogram actually has a bit of a symmetrical unimodal shape, which we're going to get into the details of in a little bit. This histogram is what you would call nearly normal. A normal graph is actually one of the nicest looking graphs in the world. The normal graph has kind of a bell curve to it, so to speak. I mean, it's not perfect, which is why I said nearly normal. In statistics, you kind of have to be fluffy. You have to be fluffy. Things aren't always going to be perfect. They're going to look close enough. And as long as they look close enough, we're in good shape. It's really nice. Is you can hit trace. If you hit trace, you can see exactly what each bar represents. And then you scroll to the right, and you can kind of see all this information. Like, you can see how many data points are in those ranges and stuff like that. It's really nice. But it does it all for you. It does it all for you. And what's even super nice, check this out. Here's the best part. You guys have an advantage over other years. If you create something in the graphing calculator, you can take a screenshot. You can take a screenshot, and you can try to edit that thing down to make it like, I just want to see that. Yeah, you could do that. It's really nice. Let's go back to here. So you turn on the plot, second Y equals enter, select the type of graph that you want, then to resize the window, you simply have to hit zoom and 9. Zoom 9 will resize that window for you. Just, super nice. Let's look at another one. Let's change the graph. Instead of looking at a histogram, let's look at a box and whisker plot. Let's look at a box and whisker plot. I don't know. Let's just do it. So I'm going to go back here. So how do I change the type of graph that I have? Where do I go in the calculator if I want to change the type of graph? Second Y equals will take me here. Now look at that. That's actually really cool because they actually have the graph that you have on still, and the others are still set to scatter plot. There we go. I'm going to go to here. You change it. You change it on yours. Change it to box and whisker. After you change it to box and whisker, you could hit graph right away if you wanted to. But if you do, what? No, it does show you something, but it does look a little off. So what you just need to do, zoom 9. If you zoom 9 it, it'll resize the window to make it look a bit nicer. It'll resize the window to make it look a bit nicer. A box and whisker plot tells you a lot of stuff. A box and whisker plot tells you a lot of stuff. You can even see right there, there's your median right in the middle. This number is your Q3. This number is your Q1. this number is your minimum, and this number is your maximum. And it just sets it all out for you right there. Just nice. You've heard the word outlier before, I'm assuming, just in casual conversation or whatever. There actually is a calculation to determine whether or not something is or is not an outlier. That's not the purpose of today. The purpose of today was graphical displays. We'll get to outliers another day. Chapa! So, I'll go back to my notes real quick. So, I'm going to be switching pages in a minute because I know you said you were taking pictures. Yeah. I just didn't want to change it and then you'd be like, hey, you know. So, let's talk about cussing. It's not what you think it is, but let's talk about cussing. To describe a distribution, a graph, really, you should cuss. To describe a distribution, to describe a graph, to describe an association, so to speak, anything along those lines, there's an acronym that we refer to as cuss. C is the center. Now, in terms of the center, you are going to use X bar, which is your average, if data is symmetrical. Now, you know what the word symmetrical means. It looks basically, you could fold it in half in the center and everything would kind of lie on top of each other. And again, in statistics, it doesn't have to be perfect, but it has to be pretty close. Like this example right here, back to the histogram that you can see in my top corner, it didn't look perfectly symmetrical, but it looked close enough. But you are going to use your X bar to describe the center of the data if it's symmetrical. And you would only be able to tell if it's symmetrical based on the image of the graph. However, what's another way to measure the center of the data besides average? Yeah, the median. But you would only use the median, that center part of the data, if the data was skewed. We're skewed. Now, what do I mean by skewed? Here's a couple examples of skewed data. Here's a couple examples of skewed data. This is skewed right, and this is skewed left. So how do you describe data? We're talking about cussing. Cuss is an acronym that helps you remember what it is that you actually have to describe about the data. The C stands for the word center. Now, for center, you would use the X bar, your typical average calculation, if the data was symmetrical. Hopefully, we recognize what the data looks like if it was symmetrical. It looks reflected upon itself if you fold it in half. Otherwise, if the data was skewed, you would use the median. A good example of skewed data would be the number of, if you had the average household income in the United States, for example, you would have a ton of people between $40,000 and $80,000. The majority of people in the United States would be between $40,000 and $80,000. But then there would be a lot less people earning millions of dollars every year. Thus, that type of data would potentially be skewed to the right. because there'd be a ton of people at the beginning and then a lot less people at the end. We're skewed. I'm going to change the page again. So, let's talk about the U. The U is unusual features. The U is unusual features. Now, in unusual features, you could be referring to something along the lines of, as we discussed, outliers, which we will have a calculation for eventually, gaps, multiple peaks, things like that. Anything that would be considered unusual, we would have to describe something along those lines, and that would be acceptable. Now, I did skip a little ahead when I talked about shapes of things, but you could also talk about shape. Now, shape, as we talked about, you could have something that is symmetric. Pretty sure I spelled symmetric wrong before. Whatever, don't care. You could have something that's skewed. You could have something that is uniform. What do I mean by uniform? What is uniform, if you had to describe it? Consistent. Almost all the same. Like flat. Almost, Like, yeah, something like that would be describing the shape of the data, the shape of the distribution. And finally, there is this measure of spread. There is this measure of spread. Now, spread, if symmetric, use standard deviation. If the data were symmetric, you are to use something known as standard deviation. As I talked about a little bit, standard deviation is like the average deviation from the mean. However, if skewed, use something called IQR, which I'm going to show you what IQR is in a moment. I'm just going to give you a brief definition as to what those things are. Each of those things. This is the last little bit of information I'm going to give you on this next page. Last little bit of information. Now, as I talked about, and I just want to make sure we have this written down, standard deviation is similar to average deviation from the mean. It's like average deviation from the mean. On average, everything seems to be deviating by like 3, or everything seems to be deviating by 10 or something along those lines. And I'm going to put a little note here in a bracket. The smaller the SD, standard deviation, the smaller the SD, the more consistent the data points. The smaller the standard deviation, the more consistent the data points. And finally, I just wanted to talk about IQR. You guys learned way back in the day, you guys learned this calculation known as range, didn't you? How do you calculate range? Range is nothing more than maximum minus minimum. But here is something. Here's a piece of information that you probably never thought that you would hear. Range is a dumb calculation. It doesn't tell you anything. It doesn't tell you anything. If you were calculating range, are you kidding me? Range is completely subject to outliers. If you have a giant outlier in one direction or the other, then your range is completely screwed up.
They told me that was important.
No, it's not. It's not. You know what is more important? You know what's more important though? IQR. IQR, ready for this? Interquartile range. IQR is more important. Interquartile range. If your data is skewed, then you would refer to your interquartile range. Now, your interquartile range is what they call a measure of spread. In fact, I'm going to write that underneath here in a moment. But to calculate your interquartile range, IQR is equal to the following calculation, Q3 minus Q1. Don't do max minus min. Do Q3 minus Q1, more important. SD and IQR are measures of spread. There we go. They're measures of spread. They basically tell you how spread out your data is. I talked about the smaller the SD, the more consistent the data points. The smaller the standard deviation, the less spread, ready for this? The less variability that you will have. The larger the standard deviation, the more chaotic things are. The larger the standard deviation, the more varied your data is. The larger the standard deviation, the more spread out your data looks. When people are collecting data, they typically like to have a very consistent, predictable standard deviation. They don't like to have a standard deviation that is large, because if that is the case, then things are just all over the place. They would much prefer if the standard deviation were much closer together. Here's just a verbal thing for you. Typically speaking, the more data points that you collect, the smaller the standard deviation actually becomes. Now, I'm going to show you something, but here's the thing. You're not going to have to know this formula. I'm going to write something on the board using this marker, but I'm going to erase it because you are not going to have to know how to do it. I may have talked about this in another class, but whatever. Standard deviation is the sum of all of the deviations from the mean squared divided by n minus 1, and then a giant square root around the whole thing. You're not going to have to know that formula. Trust me, because the calculator is going to do it for you. So you don't have to worry about that. But the reason why I throw that up there is this. It's this really messed up calculation. But again, look what they're doing. They're taking the deviations. The deviations are either positive or negative. But then they're squaring them, which makes all the deviations what? If you have a positive number and you square it, or if you have a negative number, if you square it, what happens? It becomes positive. They always become positive. But then they divide it by n minus 1, which is like kind of taking an average. It's kind of taking an average. It's like take an average, you add everything up, and you divide by however many there are. So it's like, okay, deviation squared, add them all up, divide by however many there are, except it's n minus 1. But then because they squared it, they want to put it back to normal. So they square root it back. It's a really tough calculation. But the general idea is the more data points that you have, the smaller the standard deviation. Again, you're not going to have to know that formula. You're not. Calculator do it for you. Oh, happy day. Anywho, please remember, there is something on Google Classroom for you all. I'm debating, maybe next week we'll be able to watch that video, the 20-minute video. Again, I don't really want to watch the whole thing because it's like 20 minutes, but we'll see. Maybe I'll start class with that next time, but we'll see how that plays out. Remember, Wednesday, you have that PSAT, SAT thing. So for some of you, you either are coming in to take the SAT, or for some of you, you just may not be coming in at all. But pay attention to Google Classroom, and we'll deal with that when the time comes. I'm going to sign off. Oh, happy Monday.